This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome to Chapter 1 of Climate Change, Science and Solutions, where we're diving into the story of how carbon dioxide went from being nature's recycling system to the main character in our climate crisis. We'll explore how carbon naturally moves through our planet's air, water, and living things, and why understanding this cycle is key to grasping what's happening to our atmosphere. Let's get into it. Right now, a gas you can't see is quietly holding in more heat than at any point in human history. You breathe it out. Your car exhales it. Forests and oceans try to swallow it. In this episode, we'll chase one simple question. How did carbon dioxide become the atmospheric villain? We didn't always think of this gas as the bad guy. For most of Earth's history, it played more like a quiet background instrument in the climate orchestra, steady, predictable, rarely soloing. What changed is not its basic nature, but the tempo and volume we've forced on it. To understand that shift, we need to zoom out from smokestacks and tailpipes and look at the bigger choreography. How carbon moves between air, water, soil, living things, and stone over centuries and millennia. That motion isn't random. It's more like a carefully written score with parts for volcanoes, forests, plankton, and even mountain ranges. In this episode, we'll trace how that score got abruptly rewritten over the last 250 years, who turned up the volume, how the other players are trying to adapt, and why the rhythm of that change matters as much as the notes themselves. To really see what changed, we need to step back in time. For hundreds of thousands of years, ice cores show Earth's CO2 gently rising and falling with ice ages, like a heartbeat staying within healthy limits. Then, around the late 1700s, the graph doesn't just bend, it rockets upward. Coal-fired factories, oil-powered transport, and later industrial agriculture all began adding carbon far faster than natural processes can adjust. In the data, it looks less like a gradual crescendo and more like someone suddenly switching musical genres mid-performance without warning the rest of the band. Here's where the story gets less like slow geological history and more like a human-made plot twist. For most of that long, stable past, almost all of Earth's carbon stayed locked away, buried in deep sediments, dissolved in the ocean, or bound into minerals. Only a thin, fast-moving layer cycled through air, surface waters, soils, and living things. The rest sat in enormous, slow reservoirs that usually change over millions of years, not centuries. Fossil fuels tapped straight into that slow reservoir. Coal seams, oil fields, and gas deposits are essentially the compressed remains of ancient ecosystems, concentrated by time and pressure. When we dig and drill them up, we're not just shifting carbon from one part of the fast cycle to another. We're injecting carbon that hadn't interacted with the atmosphere since long before humans existed. That injection wouldn't matter as much if it were tiny or rare. Instead, it's continuous and huge. Power plants, vehicles, cement kilns, steel furnaces, cargo ships, data centers, all of them lean on the same basic chemistry. Carbon-rich fuel plus oxygen equals energy plus CO2. The details differ, but the atmospheric outcome is the same. Natural buffers do respond. Warmer air and higher CO2 push more carbon into the upper ocean. Plants in many regions grow faster for a while. Soils can temporarily store extra organic matter. But each of these responses has limits and trade-offs. As surface waters take up more CO2, they become more acidic, stressing corals and shell-forming organisms that help move carbon into the deep ocean. As plants grow faster, they often become more vulnerable to heat waves, pests, and fires that can rapidly send that carbon back to the air. There's also a timing mismatch. Human systems can double emissions within decades. Geological processes that permanently remove CO2, like forming new carbonate rock, operate thousands of times more slowly. It's like prescribing a powerful drug, fossil carbon, faster than the body, Earth's coupled systems, can metabolize or excrete it. The dose accumulates, side effects intensify, and even organs that first helped compensate, the oceans, the biosphere, start showing signs of strain. Consider how unevenly we're turning the knobs. One coal plant can emit more in a year than many small countries, yet its plume blends invisibly into the same thin shell of air a farmer relies on half a world away. A transatlantic flight leaves a trail of CO2 that lingers longer than the plane's design lifetime, subtly reshaping future storm tracks the passengers will never see linked to their boarding passes. Data centers that feel virtual run on very physical fuel mixes, so each streamed movie contributes a measurable, if tiny, nudge to warming. Cities amplify this. Dense clusters of vehicles, buildings, and industry create localized carbon hotspots that satellites can now map in near real time. One analogy from medicine helps. Doctors distinguish between a body under brief stress and one with chronic inflammation. Our added CO2 is closer to the latter, persistent, system-wide, and able to trigger secondary problems, from shifting monsoons to melting glaciers that supply drinking water to hundreds of millions. CO2's rise doesn't just warm, it rearranges where water, food, and people can safely exist. Monsoons may shift like touring bands changing venues, leaving some regions flooded and others in drought. Ports, power grids, and crops were built for an older climate set list, so growing extremes mean more blackouts, insurance shocks, and displaced communities. The twist? Choices this decade help score the climate your grandchildren inherit, long after today's engines fall silent. We're the first generation to read this altered score and still able to change it. Future chapters could feature power grids sipping sunlight, cement that stores carbon, ships fueled by green hydrogen. Your daily choices, how you move, eat, vote, invest, are like small edits in the margin of a draft. Enough of them, and the ending reads differently. Here's your challenge this week. Track your personal carbon cycle for 24 hours by logging every activity that burns fossil fuels, driving, heating, electricity use, food choices, and then use an online carbon calculator to total your CO2 emissions for that day. Next, pick one of your biggest emission sources. For most people, it's car trips or diet, and commit to cutting its CO2 in half for the next 7 days. For example, replacing 2 car trips with walking or cycling, or swapping all beef meals for plant-based options. At the end of the week, recalc your emissions for a typical day and compare the numbers so you can literally see how your personal carbon cycle changed. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow!